I'm just gonna do a quick introduction on PyMechanical and PyMAPDL. For the people that are a bit related with the structure and structure mechanics, they might know mechanical and MAPDL. What is PyMechanical? Well, PyMechanical is basically the Python wrapper built on top of Ansys Mechanical. It's aiming to interact with the mechanical, even if it's a remote or embedded instance, which is one of the features that habilitates this library. It's allowed you to interact with the mechanical API, as I said, so you can use the same kind of command, the same kind of API objects, the only script that you are used to. You can use them still in PyMechanical, and on top of that, you have additional plotting capabilities. You have a different way of interact with the same objects, more Pythonics. This is just to remind you that how this mechanical code can be obtained through the mechanical desktop app. You can reuse this approach to record code and then just plug this into a PyMechanical script and being able to execute it. So we are talking that you have this access to the same mechanical features through Python scripting, which is very interesting if you ever want to use in a remote environment, or if you want to use it in another environment, like maybe cluster or something like that. It's also allowed you to interact because you are using Python at the end of the day. You can use other libraries. You can couple the code with other libraries. Like, for example, in this case, we have PLT, which is matplotlib. You can use that to do plots. Of course, you need to couple the code as in mechanical with the code as you might use it with matplotlib, with NumPy, with pandas, wherever is the library that you prefer. As I say, there is one way to, this new feature, let's say, in terms of using Mechanical, which is that now you can use it either remotely through the gRPC server, where you submit your code to different mechanical instances that might be running on your PC or in another PC. This is a very interesting feature if you are planning to use big models, because you could just use a normal laptop just to submit the code, and then that big PC with the mechanical instances will run your simulations or will perform the pre or post processing, etc. So it's quite interesting. Additionally, you have the embedded instance, where the mechanical will run as part or inside the Python process. It will require more. You might be limited by the amount of memory RAM that you have in your PC, but in principle, is relatively lightweight, so it should be okay for most of the main uses. We are trying to foster, as David say, the open source community participation. We encourage everybody to have a look at the documentation, to go to the respectively repository, GitHub, and then post there the issues and open questions there, or to contribute either suggesting features or developing code or creating examples. As David said, there is now two ways to get help for this kind of libraries. You have either the GitHub repository, more developer-oriented, I would say. There is where all the development in terms of code is done. So if you have something like related to implementation or things like that, might be the best place to ask it. If not, if you have maybe a more related question with the usage, you can probably go to Ansys Developer Portal, because there is a lot of colleagues that work for Ansys, and they are expert in use this kind of library, so they can advise you the best on how to use it. Anyway, more or less, both sources are interchangeable, but I will say more or less that's the main goal of each one. GitHub for developers and developer portal for users. As I say, you can ask questions and GitHub repository discussions. You can open issues, as I say, related to implementation or errors or bugs or something like that. And you can also check the code, the source code, which is also can be very useful in terms of understanding what is happening behind the scenes. So it's quite recommended. So now, as I said, this is a brief introduction. So let's go to PyMAPDL. So what is PyMAPDL? Well, I guess a few of you might know if you are you have worked a lot with the structure mechanics, you might have heard about MAPDL. It's the solver. It's used also by mechanical, but it's behind the scene. You never get to interact much unless you are using command snippets. So PyMAPDL is the Python wrapper that is built to interact with MAPDL instances using Python or MAPDL commands. So this is PyMAPDLs allow you to interact with MAPDL either in a Pythonic way, as shown on the left, or you can even plug or copy paste your old APDL commands. Just input the strings directly, which is quite interesting if you're if you want to reuse the old APDL code that you might have. You can also use the converter module to convert the MAPDL code to PyMAPDL automatically, which is quite convenient also if you plan to take advantage of the new features, because there are new features or there are expanded capabilities that PyMAPDL add on top of MAPDL solver, which, for example, could be the plotting. You can now use more interactive Python plotting libraries like PyVista or Matplotlib, but you can also use the old MAPDL backend if you wish. So it's quite of a new feature, you know. Oh yeah, and then because, as I say, it's interactive plotting, you can drag, zoom around, and it's quite useful. It's also PyMAPDL also allow you to interact with MAPDL arrays as Python objects, so you can set arrays in a easier and more convenient way, and you can retrieve values. For example, nodes, an array of nodes, array of elements, etc., in a easier and more convenient way. You can also set strings, string arrays. So it facilitates the usage of MAPDL in your day-to-day basis. Of course, it's also allow you to interact with other libraries for either pre-process, post-process, for reporting, whatever you feel like or wherever you need. There is always a Python library that do that, and we are more than happy to allow MAPDL to interact with it. We see here just example on how to plot the node temperatures on the node 12. Additionally, we have things if you are running MAPDL locally, meaning that the instance is running on the same computer as the Python process. You can also launch the MAPDL GUI and interact with the model and change the model, and then those changes will be reflected in the model. Okay. As I say, one of the main advantages of PyAnsys product, PyAnsys libraries in general, is that it's easier to couple with Python ecosystem. We are providing an API to do that, and we are already using some libraries behind the scene, like NumPy, like SciPy, etc. And on top of that, we are providing some examples that interact with other libraries. We have some machine learning examples using genetic algorithms and force machine learning with TensorFlow. We also have an example about meshing with Gmesh, which is open source tool. We also have an example with Dash to build your own web apps, and also to build your command line interfaces or graphical user interfaces. So these libraries are pretty flexible to build your own custom app, whether it's web app or desktop app, or you just want to run some simulation. So it's very useful. How does it work? I did mention on the case of PyMechanical that you have embedded or remote through gRPC. Here we have a gRPC channel only, but it's quite useful because you can, as I said, you can locate one of the instance in a cluster, and you can connect to it and run your simulation in the cluster, and it's much, let's say, resource efficient in terms of not overloading your laptop or maybe running big simulations, etc. And the PyMAPDL, we take care of transferring those files that are needed through the gRPC channel. So it's quite complete in terms of adding value to your day-to-day work. Again, we would like to remind how to get the information on how to use this library. We have the documentation website, which I share on the chat, where you can learn how to install PyMAPDL, how to use PyMAPDL. You can see those examples I mentioned before. Of course, you have the Ansys developer portal to ask questions. You have the GitHub repository to suggest feature, develop code, or create examples. You can also ask questions in the discussion tab in the repository, or if you want, you can use the Ansys developer portal. Is up to you. As I say, there is a more developer focus on the GitHub repository, and more user focus on the Ansys developer portal. Nevertheless, to say, you can still use both. If you have any trouble with the library, like something does not work, something it shouldn't work like that, it should work in a different way, or you have any suggestion or any feature, those are very, very welcome. We are always happy to see interaction with the community. So we are really encouraging people to open issues on the repository and check this GitHub repository or documentation page, so we can get feedback from the community. That is what we want to foster. And again, you can check the code there, examples, documentations, and features.